In 2026, the enterprise baseline for artificial intelligence has shifted past stateless, reactive conversational AI. The new standard relies on autonomous, goal-oriented AI agents. These agents resolve complex workflows independently. In customer service deployments, companies are recording up to 40% faster response times and a 60% increase in ticket deflection rates. The adoption rate matches these efficiency gains. Across the Microsoft 365 ecosystem, the deployment of active agents has grown 15 times year-over-year. Yet, despite this massive scale-up and clear technological superiority, systemic enterprise return on investment is stalling. Neither a lack of advanced tools nor a deficit in individual talent explains this stagnation. Acquiring agentic technology does not automatically translate to scaled business value. Realizing that ROI requires a structural shift in enterprise architecture. To diagnose this ROI failure, we can examine telemetry and survey data collected from 20,000 enterprise AI users across 10 countries. This chart visualizes the transformation paradox. The vertical axis measures organizational readiness, while the horizontal axis tracks individual capability. In the top right, we find the frontier quadrant. Here, 19% of users benefit from high individual capability and strong organizational support. Contrast that with the bottom right quadrant. This 10% represents blocked agency, highly skilled individuals operating within unsupportive environments. These blocked users represent wasted capital. Legacy evaluation metrics, misaligned incentives, and outdated behavioral norms artificially constrain these highly capable employees. The data points to a precise conclusion. Extracting impact from AI is no longer a matter of training individual skills. It requires total systems design. Capturing agentic value requires leadership to step back and re-architect how work is orchestrated, evaluated, and governed across the entire firm. To understand why these legacy management structures trap capable users in the blocked quadrant, we have to look at the technical layer of an agentic workflow. A traditional chatbot requires a linear, human-generated prompt to execute a single task. A fully realized AI agent operates on autonomous, goal-oriented reasoning. This outlines the agentic architecture. At the base, environment perception independently reads APIs. Data flows into the decision and orchestration layers, fracturing the goal into executable subtasks. In the action phase, payloads trigger external systems autonomously. Finally, memory and feedback loops optimize future routing. Because an agent operates as a continuous, self-optimizing engine rather than a static tool, applying static legacy management evaluations to it will inherently bottleneck its execution. Deployment of autonomous agents does not remove the requirement for human intensity. Human cognitive investment is relocated to higher-order tasks. This chart plots agent intensity on the horizontal axis against human intensity on the vertical axis. As agents absorb complex tasks, human involvement migrates from direct manual generation in the lower left upward into high-level supervision in the top right, retaining full responsibility for outcomes. This establishes a new human mandate. The operator's role is defining clear intent, setting the quality bar, and enforcing critical constraints on the agent's autonomy. The nature of human work has been elevated out of repetitive execution, entering the realms of system design and rigorous quality control. This shift in human intensity explains exactly why traditional organizational models are breaking under the weight of AI deployment. This random forest analysis tests 29 factors against self-reported AI impact, grouped by organizational traits in purple and individual traits in orange. The finding is stark. Organizational factors dominate, accounting for 67% of AI value, while individual behavior accounts for only 32%. The components driving that 67% share are clear: a culture that supports experimentation, active manager modeling of AI workflows, and updated talent practices. This context explains the exact failure point for the blocked agency individuals we identified earlier. They possess individual capability, but lack the organizational support required to execute at scale. When a firm lacks an established evaluation infrastructure to review autonomous output, even the most advanced workflows hit a hard ceiling. Operating without documented human handoff protocols and leaving agent security permissions unverified introduces severe friction, forcing users to manually override and double-check systems that should be autonomous. Investing capital heavily into individual AI upskilling will yield rapidly diminishing returns unless the surrounding evaluation and governance infrastructure is upgraded in parallel. To transition out of this blocked state and enter the high ROI frontier quadrant, an organization must implement concrete architectural solutions. The necessity of this rebuild is driven by a specific compounding risk factor. When agents execute autonomously at scale, the cost of a single bad output multiplying across interconnected workflows is catastrophic. The baseline requirement is an agent-native evaluation infrastructure. A firm must establish strict protocols defining exactly who reviews agent performance and who holds the authority to update the underlying workflows. This illustrates the necessary IT architecture shift. Security teams must treat autonomous agents as managed network entities, wrapping them in a dedicated control plane. This involves assigning unique identities, enforcing access permissions, and tracking agent lifecycles just like human employees. Security, auditability, and IT visibility cannot function as afterthoughts. They must be baked into the structural properties of the system to safely authorize agentic autonomy. When a firm is properly architected to manage this autonomy, it realizes a unique strategic advantage: the creation of owned intelligence. This begins by capturing telemetry from isolated, successful human-agent interactions scattered across different departments. Local operational wins are extracted, verified by supervisors, and encoded into centralized routines. This continuous feedback loop transforms the company into a self-reinforcing learning system. This uniquely tailored institutional memory compounds, making it virtually impossible for competitors to replicate. The organizations winning the AI era are those with a systems architecture that learns and adapts faster than its competitors. Watch these isolated digital nodes rush together, locking into a highly structured, synchronized network grid across the enterprise. This timeline tracks the velocity of enterprise AI evolution. We start in 2021, when the technology focused on basic predictive text. By 2023, we transitioned to the conversational era, using large language models to generate text, code, and raw data. Evolution continued into 2025 with the rise of single autonomous agents, isolated assistants executing multi-step tasks for individual users. In 2026, we have reached the era of multi-agent coordination, where independent agents communicate and negotiate with one another. Inside the Microsoft 365 ecosystem, active agent adoption is currently tracking at a 15 times year-over-year acceleration. Within large enterprises specifically, that growth trend steepens to an 18 times increase. As these agents move from isolated tools into a synchronized network, managing the enterprise becomes less about overseeing individual code and more about orchestrating the connections between these systems. Navigating this shift requires addressing a specific tension. The massive economic potential of these systems often conflicts with the immediate need for measurable risk governance. This split-screen chart illustrates the financial cost of traditional customer service. On the left, baseline expenses for human-operated ticket resolution. Azealand Technologies data shows manual ticket resolution costs an enterprise between $5 and $12 per interaction. In a multi-agent architecture, the unit cost drops to between 10 and 50 cents. This 98% cost reduction is paired with a 40 to 60% deflection rate, resolving issues before they reach a human queue. Wayfair applied this e-commerce model, reducing average handle time by 10%. Vodafone's Super Toby achieved a 50% improvement in first contact resolution. Domino's North America uses voice AI to handle 80% of phone orders. These cost shifts are now moving beyond digital interactions and into physical operations. McKinsey reports that agentic workflows in physical operations yield productivity gains of up to 40%. Siemens recently used agentic coordination to reduce factory downtime by 30%. Multi-agent systems erase traditional operational overhead by automating the entire lifecycle of a service request at an absolute global scale. If unit economics drop from $12 down to 10 cents, the logical outcome should be full global deployment. However, most enterprises are still struggling to scale. The Microsoft Work Trend Index maps this gap. The x-axis represents employee readiness, and the y-axis tracks system constraints. Data points on the far right show employees are prepared and eager. At the same time, rigid risk models act as a downward force, restricting transition. This creates a bottleneck where only 19% of enterprise workers operate in the frontier sweet spot. This stagnation for the rest of the workforce is not caused by a lack of technological capability. Moving the workforce forward depends on establishing an architecture that handles enterprise risk at scale, requiring a strict, mathematically measurable governance framework. The governance style provides the architectural structure needed for safe deployment. The first setting is human in the loop, or HIDL. This requires explicit human approval before execution. Next is human on the loop, where agents execute autonomously, while monitors maintain instant override. The final setting is full autonomy, operating end-to-end without human oversight. There is a common assumption that full autonomy is the appropriate goal for all enterprise functions. However, leadership at Truist Bank notes that in customer-facing and banking sectors, unmonitored execution is often blocked by regulatory and brand requirements. User research confirms this. 71% of professionals prefer a human-in-the-loop setup for high-stakes decisions. Determining which of these three dial settings to use requires a diagnostic framework. That framework is a 4-axis radar chart, evaluating dimensions of risk. The first axis is reversibility. Can the action be easily undone? The second is regulation, measuring compliance with legal standards. The third is consequence, evaluating the financial or reputational damage of an error. Finally, we track performance history, the proven accuracy of the specific agent. In a high-risk scenario, such as financial services, the high scores for regulation and consequence create a mathematical mandate for a human-in-the-loop setting. Using these precise mathematical constraints is exactly how large enterprises safely move their entire global workforce into the frontier sweet spot. If we move from internal operations to the broader market, we see how these systems are changing the macroeconomics of software procurement. As multi-agent systems execute entire enterprise workflows, the traditional software valuation model, centered on the human user, has shifted toward the value of the completed task. In the traditional model, procurement is based on seats, or the number of human user licenses. This pie chart shows the majority of enterprise SaaS spend is currently tied to seat-based licenses. Deloitte predicts this model will soon decline. As agents take over workflows, the need for individual human seat licenses is shrinking as a percentage of total spend. Usage-based and outcome-based pricing models are expanding to fill the resulting economic gap. By 2030, these outcome-driven models are expected to capture 40% of all enterprise SaaS spend. Enterprises are increasingly deploying agents paid for by the specific outcomes they produce. The future enterprise is a multi-agent machine, orchestrated by human conductors, managed through precise risk dimensions, and measured